let me just do introductions, I guess. It looks like, because instead of...
You look very important with that angle, though, Bill.
So why don't I call people out? That way, Rob?
Do a roll call.
Yeah, so we know, because everybody's square is going to be different. Like I'm going to be in a different spot, I guess. So Ted, why don't you go ahead, and then I'll call on each person to introduce himself. So Ted, go ahead.
Ted, K3 Romeo Tango Alpha in Bear.
Mark?
Mark K3JJ in Newark.
Robbie?
Robbie W3RSM in Newport, along with Gail W3GLM across the room now.
Wayne?
Wayne K3WHH in Newcastle.
Frank?
This is Frank, 83M in Tallyville.
I like that headset. That sounds good, too. John Rowe?
This is John Rowe, N3BRY. I'm up at Westchester University at work.
Rob?
Rob, N3FJ. I'm currently in Chad's Ford home. One thing, just a tip with Zoom that I've learned: if you're on a computer, if you're muted and you want to talk, as long as Zoom is focused, like it's the program that's the focus of Windows or Mac, you can use the space bar as a push to talk button.
Oh, awesome.
I was just about to note that.
Captain Scott? Dave?
Yeah, hi, everybody. Dave, KC3BEJ.
You cut out there towards the very end, but we got you. Alan?
Alan, K3AAA in Newark.
Don DiGiovanni III?
Don, KC3FMU in Newcastle.
Tom?
Tom, KC3FAU in Middletown.
The other Don?
Yeah, this is N3NJI, Don in North Wilmington. It's good to see everybody tonight. I think this is really cool to do virtually. Rob, thank you for organizing it and sending out the invite. And we may be doing this for quite some time, because Christiana Care is not going to be hosting any on-site meetings up until the end of not until 2021, I should say.
I was talking to John earlier. We may be doing it for quite some time because of this roster we have here, as opposed to the in-person one. I'm sorry, Ted.
Yeah, Ted.
I was going to ask, how many of you guys in North Wilmington are going through the mesh network to do this? That would be like really geeky and cool.
Paul would be happy about that. I'm not at this point. I don't have that capability at this point yet, or at least with wirelessly. Let's see, Bill, you up next?
Yeah. W3DE here. I believe I was talking with Rob on 7.3, and you said you were going to monitor 7.3 to see if anybody else is going to join us.
I gave up because I guess there's something wrong with my system. I wasn't getting in. So I asked.
This is true.
Without a call or
you
two,
were very noisy.
Which is weird.
I think it's your $30 mic.
Well, he's fine on 4.
Actually, no, it's the one that came with the.
On 448.375, he sounds really good. It's something on the 2-meter side.
Yeah, there must be something. There must be SWR must be through the roof on it, and because I can't even read it that well, I get like 2 bars and it usually buries the needle.
Jill, you want to go ahead next?
Yeah, this is Jill N3ICE in Hockessin, and hopefully you can hear me because my stuff says my computer is unstable, whatever that means.
You sound perfectly fine. Wendy?
Like mentally unstable?
This is Wendy, KB3ZDM, and I'm up in Pike Creek.
Ken?
Ken, NU3A in Newark.
Looks like
and there's Paul. And there goes Paul.
Hi. Paul, K3PGM, and I'm in Hockessin.
And this is John, N3LUD, and I love seeing everybody on the camera. This is great. I'm getting a kick out of this. I think it's going to work out well. I like Paul's book collection there behind him. And
Only a tiny part of it, actually.
wow. No, good to see everyone this evening, and thanks to Rob, and thank you to ASPA, Anesthesiology Associates, I believe is the company name, for allowing us to use, or they're sponsoring the meeting because they're letting us use their Zoom account to be able to do the meeting for free. So I'm really grateful to them for that. And Rob's going to do a presentation this evening, but before we do that, let's just kind of cover a couple things, I guess, or a couple things that I had some notes earlier. I don't know what I did with them. Robbie was asking me recently about when we can possibly resume the VE sessions. Robbie, you just heard what Don said probably a little while ago. It sounds like right now, it was the end of June, and now it looks like they're probably not going to resume like larger meetings till the end of the calendar year, after the end of the calendar year. Meetings in work, they're basically saying not more than 10 people are allowed in a meeting if they could do the 6 feet apart distancing. So I think that'd be pretty difficult to do probably the testing that way. So at this point, we're probably not gonna be able to do the testing until after December. I don't know what the options are for virtual. I know a lot of folks are doing stuff online virtually with testing and so on. Also listening to the Leo Laporte, Ham Nation by Twit TV, Bob Heil and company. If you guys watch that video podcast each week, I don't watch it every week, but here and there I watch it. It's very good. They've been talking about a lot of different ham radio clubs doing Zoom meetings, and the attendance of who's coming to their meetings is actually up. And people that even maybe don't have the capability to get out of their homes are able to even attend the meetings and so on. So Rob and I were talking earlier, and we're thinking because of the attendance, if the attendance was good, we would keep this up, do the next one in August. Maybe we could even do the meetings every other month. We were doing them quarterly because I know it's hard for people in person, but maybe we do 6 meetings a year with one meeting that we do in person. So like, is there something we need to see or to get hands on? I know from time to time we have some meetings like that where we've done things or go kits, things like that. So maybe that would be, maybe that would be decent to try that out. Not that it makes a difference at this point, but I think I mentioned a couple weeks ago, they told us we don't need to use flu hang tags anymore on our badges. It's not that makes a big deal because if you did go to the hospital now with your badge, like if you were doing volunteer stuff, not that I would ask you to go to the hospital, you do need to go in an employee entrance and answer questions, and they'll take your temperature and so on. So at this point, I would just encourage folks to not go to the hospital. Like, if you were inclined in going to the radio room and things like that, I would just say for the time being, maybe not to do that. Myself personally, I've been working from home, and I've been doing maybe one day a week in the office, or I've been hitting Christiana or a couple different places. Next week, tomorrow I'm working in the office. Next week I go back to 3 days, and then the following week I'll be full-time back in the office. That's my plan at this point. So as things progressing in Christiana care, from that perspective, I'll certainly, communicate that out to folks. Another thing that I wanted to mention, Dave, Scott, and I have been talking about possibly using a different repeater, at least to try out. There's folks that are south of us. Al and Ken are ones that I'll call out. I know Wendy sometimes has problems getting into the repeater. Connie, even up here, has problems. She's near the city. She has problems getting into the repeater. Several folks have asked us, could we do 448-825? Because that has really good coverage. We can start getting more people downstate. I think First State Amateur Radio Club they're going to start doing their meeting that way, and so on. So I think one of these weeks we're going to try doing a net on 448-825. Not that I'm anxious to abandon any of the DRA repeaters, and I do appreciate the use that we're allowed each week to use that. I know there's just difficult, you guys know, there's difficult copy and so on, and then maybe getting people in that way. The other thing, as an alternative, I was going to bring up to offer to people is, we'll try 448-825, see how that works out. And then when Jerry, KB2GCG, was living in Virginia for 2 or 3 years, every week we would Skype, and I would get him into the net on Skype every week. So we would be connected, and then when it was his turn, I would hit the push to talk button. I'd give him a thumbs up, and then he would do his thing, and that worked really well. So I would say, maybe we set up a Skype set or a Zoom session, and Jerry and I did Skype, but maybe we do a Zoom session, and we get people to check in that way via Zoom. And I realize people will say, well, that's not ham radio, but at the same time, there's some people that want to check into the net that can't check into that are not able to check into the net. So more information to come there. I was interested to find out and maybe we could do a poll, Rob. I don't know. Maybe you just did a poll there. Maybe we do a poll, or maybe you guys can send me email. We don't need to put people on the spot. So I'd be anxious to hear about your thoughts on 448-825. Rob, for one, and Chad's Ford may not be able to hit that repeater.
I don't think it tells you what individuals say in the poll.
Okay. Well, maybe let's try it real quick. If you want to just put together how many people want to try the net on 448-825, I'd be anxious to see what the percentage was. And 448-825, field day. I'd be anxious to hear if anybody's talking about field day. What are some of the plans there? I know up north, KC3AM and John, KB3MLT. I haven't talked to them. I've talked to them individually. I've talked to W3DE individually. I know Dave at one point was thinking we would be able to all operate from our home and use W3DE's call sign like we would be in the field. I don't think you're allowed. Actually, I know you're not allowed to do that. I asked Bill to check with the ARRL just to double check so we don't get into debates with people. Yeah, you're allowed. No, you're not. Like, what's the official ruling? Clubs I've been reading about that have been getting together as a group doing field day have opted to do it at home and just do their call sign and do individual points, things like that. So I'd be anxious to hear if anyone has heard anything about gatherings for field day. Now that the governor's lifting a lot of the restrictions, I guess, starting next week, it'll be interesting to see what happens by the end of the June. If the numbers stay the same or the numbers drop, then maybe it's not a big deal. Maybe we could social distance. I don't know. It's kind of, there's a lot of sitting around. We talk to each other. We're up working on stuff together. It'd be hard to really social distance and kind of enjoy field day, I think. So I'd be anxious to hear if anybody, oh, that's pretty interesting. Yeah. Try split, so you see Rob's pop up. Should we try the net on a new repeater further south? Yes, no, or try a split net with relays for people who can't hit. So, anyway, I just voted there. Yeah, this is kind of cool that you could do the voting online like that. Rob, anything else in the way of announcements? Anything hospital or Christiana Care or COVID specific? You're not on.
Nothing really specific at this point. I mean, there's nothing that I can think of.
Okay.
Just I'm curious to see personally what happens in about a week to 10 days from yesterday.
Yeah.
To see if numbers
absolutely.
Shoot up. Yeah, to see if numbers shoot up, things like
that. There
was
a lot of chicanery yesterday, I think.
So Rob, do you want to get started on your presentation, and then maybe, I'm not sure how long his presentation is going to be. Typically, like you guys know, we'll have people call out and see what other little projects they got going on if anybody wants to share. There's two things that I can share that I'm working on ham radio related at the moment. But Rob, you want to go ahead and jump into your prepresentation?
God, can I get a couple of announcements for you?
Oh yeah, sorry, Dave. I meant to go to you. I apologize. Go ahead.
Yeah, not a problem. Just John's comments about the Delaware City repeater. Last week, I finally did get in touch with the repeater trustees. Finally got an accurate email, and I did get the okay from the trustees to run some nets and do some Aries stuff on 448-825 down there in Delaware City. A couple of weeks ago, we did have the second and fourth Wednesday FSARC net on the Delaware City repeater, and the feedback was overwhelming. We had people that I heard somebody cutting in there. It was overwhelmingly positive feedback that a lot of folks who just can't hit 73 were able to get to Delaware City. So just to echo your things, we do have the okay from the trustee to run nets and do Aries work on that. So that's good. And again, just a reminder that a week from Monday, not this coming Monday, but the Monday, June 8th, is the Delaware Repeater Association quarterly meeting. It'll be a Zoom meeting. Thank you to Jerry for offering up his Zoom account. I think I would ask, I can send pretty much anybody who goes to DRA is on my First State or Aries list, so I can get that information out to everybody. I think I already did, but let me ask. I see Mark there, K3JUJ. He was also going to send that out for the DRA stuff. Mark, have you done that?
I did change the meeting date on the DRA to that it was a Zoom meeting.
Right.
But I didn't put particulars in there.
Okay, I'll get you the. I'll forward you.
Well, I haven't approached the county yet to see if I can get the key, even.
Well, I don't
wasn't going to do that. I wasn't going to do that until June 1st. So I doubt very much that they're going to give it to me. And I think this progress is essential.
Yeah, I think it would still be too early for face-to-face. So, like I said, we have the Zoom thing set up. So my English is let's just do a DRA Zoom at least for June, and then regroup in
in September.
Yeah,
I agree. I agree with Dave.
Okay. Yeah.
Well, so
I'll
I'll make sure everybody gets the. And thank you to Jerry. I think it was a KB2 GCG. I think Jerry's call. I'll get that. I'll get the meeting ID and password out to everybody on that. And then we will have tomorrow night at 19:45 hours, the second and fourth Wednesday. That'll be the First State Amateur Radio Club net. We will use the Delaware City repeater again. And one last thing for all my Aries people, which I think is most. I think most of the people on the call tonight have already responded back to me. About a month ago, I asked you to let me know what the phone carrier is because I'm developing the capability of blasting out a text. If there's something urgent that we need to activate Aries, I can blast a text out to everybody, which is better than an email. I think the vast majority who have let me know what your if you're Verizon or T-Mobile or whatever it is. I need to know that so I can program in for a blast text. So most of you have done so. If you haven't, not mentioning any names, Wendy Horn, but please just email me let me know carrier so I get you on the automatic text blast out. Okay, thanks a lot. Appreciate it. I think that's all I got. Thanks.
All right. Thanks, Dave. Appreciate it. Does anybody have anything else in the way of announcements that they would like to share with the group before we move on to Rob's presentation? Rob?
So I'll mention one thing to answer your question about field day. I'm putting together a plan for First State to do a virtual 2E or remote 2E, where we have two people's home stations that we use, and we have people operating them remotely.
Oh, wow.
So some technical issues to be addressed for that, but got most of them figured out, I think. And we just need, we have two radios, two club members who have Flex 6400s have offered to make them available for remote operation. But we only have one site right now, so we're still trying to find a second site. Somebody has a good antenna.
And how does the call sign, what call sign are you using?
So we're going to use the club, well, we usually use K3F for the field day.
Okay.
So yeah, the plan is, said we'd be operating 2Es. We'd have one station doing phone and CW and one station doing digital modes.
So you could do that. You are allowed to do that if you're virtual, like together using the same. You're together virtually.
That's the number of transmitters, right? Not the number of people.
It's yeah. I mean, as far as I can tell from the rules, unlike Class A, there is no physical size limit on the footprint of your station. So I figure as long as it fits within Delaware, it can be a 2E station.
Okay. Okay. Interesting. Cool.
And there's certainly no rule that says that the operator has to be physically present at the radio in order to operate it.
Yeah, it even specifies. I did just look it up. It specifies it can be either locally or by remote. So they do have add that exception in there.
Okay, interesting. What are you guys going to do for logging, Paul? How's the logging going to work?
Well, so I think I have figured out how to get the N3FJP stuff to work over TCP, so we can
mesh.
Well, yeah, maybe. But yeah, we can operate them over TCP and have them all connect to each other. So the only thing I'm not sure about is the licensing, because currently the licensing says you only need one license if you're running as under one call sign at one site. And so the question is, what's a site? I mean, if I declare that I have this big virtual site, is that a site? So I've
could the radios be at the same site?
No, because we don't have two antennas at the site. We don't have two antennas at anybody's place so far who's volunteered anyway.
Well, if you use what about a like a bandpass filter to do operate on different bands with the same antenna?
Yeah, you could, but I mean, I think that's maybe, I don't know, the tail wagging the dog if the problem is just the logging software licenses.
Oh, the logging software. I thought you meant the FCC license.
Yeah, the logging. Yes, the N3.
I don't know.
It's the N3FJP, almost like your call sign.
Why don't you just shoot him an email and ask?
Yeah,
I'll let you do it.
I've asked Jerry Simonowitz to do that since he's the one who has the relationship with him.
And Paul, maybe we could talk offline. I was thinking that, like, because if we do that up here, I'll need to get that software working over the internet. I've done it every year, obviously over the same network, but
right.
And so I imagine you have to have port forwarding turned on and stuff on whoever the central computer.
That's basically it. You have port forwarding and you tell the thing to operate over TCP.
Yeah.
You put in the right IP address and supposedly it just works.
Yeah, I've done that no problem on the same network with the private IPs, and I thought, all right, well, if we had to do that, then whatever IP we're using, just have the port forwarding on and stuff, and that should probably work. So, well, that's good.
Might also not be a bad idea to isolate that to a VLAN on whoever's router ends up being the main.
Well, it's only
based on that.
Yeah, and it's also only for 24 hours, not even. So, or
Yeah. I mean, for example, if we put the main site here at my house, which is not a ridiculous idea because I have lots of bandwidth, I have a separate DMZ LAN that I could put it on.
Okay.
Yeah.
But you know, those are small details. We'll work that out. The bigger.
Yeah, if you can't trust the 3 or 4 people operating your station by remote to the network, maybe they shouldn't be on your radio either.
So Rob, you want to go ahead and go into the presentation?
Let's see if I can make this happen.
What is the presentation tonight? 3D printing?
3D printing. I'm calling it 3D printing and amateur radio, but heavy emphasis on the 3D printing part.
So before Rob goes into this, or as he's pulling that up, we've been doing some stuff. Rob started a GoFundMe page a couple months ago, and he's been printing. He's been doing some stuff with face shields. He can expand on that. And then I've been printing face masks on a printer we have at the Innovation Center, which I brought home about 10 weeks ago. And I've been doing face mask straps, not actually the face masks, but straps. They save their ears. The people that are wearing them long term are getting their ears cut. And I've been doing about 80 a week, 85, 100 or so, depending on it takes an hour to print one. So I've been trying to, keep that going as long as I can do it. So there's been a lot of these different 3D printing projects that have popped up when COVID-19 hit. People are doing shields, which were one of the most popular things. Rob could expand on that because he has firsthand experience creating a bunch of different varieties. Some people were actually doing N95 masks, trying to put some filters in. Rob and I both were on various different phone calls with people around the state. There was a group of school kids up here in Brandywine School District and Brandywine High School. They were doing stuff for Frederick, Maryland, where there was an adapter for for handbagging someone. If someone goes into cardiac arrest and they're on a ventilator and you connect an AED to them, you can actually fry the ventilator. So they they needed to come up with an adapter that they can put a filter in, so they were printing that. So we were on all these different calls. It was just interesting to see how people were coming up with different things and using different materials. And so anyway, I wanted to just say a little bit about that before Rob goes into his spiel.
Any questions or anything? Any comments before we get started? Oh, I'm going to be looking. Got to figure out. I have two computer screens, so that's why I've got the weird camera angles here. Okay, share screen. So let me mute everybody just to. And then, can you still hear me? Just nod. Yes. Okay, good. You should be seeing my screen now. Is that good? Okay. So I was trying to think of something to talk about here, and I kind of went with 3D printing. It's sort of been a theme for the last month or two, and figured that it might be something that people are interested in, but don't really have much information on. So I thought I'd talk about it. I don't have anything in here specifically about the project that I was doing. I kind of almost thought about it briefly, but intentionally left it out. Didn't want to toot my own horn type of thing. But I'd be happy to answer any questions about it. And I actually have an example in my hand, which you can't see because it's you're seeing my screen, which I could show you of the mask that I was making. So additive manufacturing is the overarching topic that 3D printing falls under. So I'd say just do a little thought experiment here. Imagine a world where you can click on a button, whatever you could possibly want, show up your door within 48 hours, 24, maybe 12 hours. Oh, wait, that's Amazon. How'd I put that there? Okay, now imagine that the thing you imagine doesn't exist. I'm like, really, you're the first person ever to think of this amazing thing. And now imagine it could be in your hands in a couple of hours, even if it's a complex 3D object. And that's basically the power that this technology, or it's basically a class of technologies that puts in our hands. And very recently, in the past couple of years, it's become quite affordable. I actually paid more for my color laser jet than I did for my one 3D printer that's sitting next to me here, if you can imagine that. With traditional manufacturing techniques, you want to make a part. You're going to have to design it, obviously, and it's going to take a while to do the old-fashioned way on paper. You'd have to test it, hand build a prototype, and put it through its paces, which is going to add more time. Then you got to figure out how you're going to make this thing, and a lot of times it's pretty expensive because you got to customize the machines that build it, even if you're doing vacuum forming or something along those natures. It's a very complicated, expensive project. And then obviously you're going to pump one or two out, test it to make sure that your scaling up of production didn't cause the whole thing to fall apart, which it most certainly probably does on a lot of occasions. In other words, it's very time-consuming and expensive to manufacture anything but a prototype in the old paradigm. So that's, you pretty much have to use the economies of scale and ramp up pretty quick and sell a lot of units to justify anything. So something that has a very small market or is very specialized is not gonna find its way into this design pipeline just by the nature of the difficulty of doing it. Enter additive manufacturing, or colloquially we'll call it 3D printing. This is you can design the object right in a little computer widget, either a full computer-aided design software, 3D modeling, and there's even free online versions like Tinkercad, which we'll talk about in a little bit. You obviously always want to test, but you can actually with a lot of these softwares test the function of your object, right, and simulate it right on the screen and render it in the computer. So it does take out a lot of the testing, and then you basically just then tweak your model in software called slicing software that calculates the instructions that go to the printer. And then you print it out. And depending on the complexity of your design, I've had simple things that I've designed that took me about a half an hour to design, and then within an hour or so, if it's small enough, you can actually have it in your hand, which is really cool. In other words, this whole process is cheap. It's quite fast. It's being used a lot in industry for rapid prototyping, and to print examples of things in order to put them into the old pipeline, because one of the drawbacks of this is that producing huge numbers of things is a lot more expensive. Like individual items are going to be more expensive to produce. And so other than the time you take to design the object, even one-offs are now very economical. When I say expensive, I'm talking in relative terms, in terms of the economies of scale. Like these little face shields that I printed, I calculated just the 3D printed part costs about 37 cents, which if you were making 10 million of them would be exorbitantly expensive. But when you're making one or two of them, anyone can throw 36 cents at something. So that, like, if you're making huge numbers, you'd have to crank it down to like a couple of pennies a piece at the worst in order to make a profit. So I've been going on about how wonderful it is. Now I think I should probably talk a little bit about what it is. As I've alluded to, it's a type of additive manufacturing, which is contrasted with a very similar technology which is out there. Let's see, CNC milling, which is subtractive manufacturing. This means that it tends to be more efficient because you only extrude out the material you need instead of starting with a block and cutting away the material you don't. The CNC is sort of comes along. I think it was Michelangelo said that the marble already had the statue in it. He just removed all the parts that didn't need for the statue. That would be CNC milling. This is where you actually like squirt the statue out of a little a tube here. So the way it works here is that layer is added until the final product emerges on your build plate. And one of the really cool things about this technology is that you can actually print, if you're good with the design software and know how to slice it properly, you can print multi-part functional objects that are already assembled on the build plate, which is kind of cool. It's a little bit, that's a very advanced type of things. Like, although there are things out there, like I printed a little dinosaur that had articulated a tail and whatnot, that all the articulations were already attached to themselves when it came off the printer. Now, there are different types of 3D printing out there. I'm not meant to be completely exhaustive, but they fall into general categories. There's the original idea of 3D printing was invented, I think in the late 70s and early 80s, if I'm not mistaken. It was a technology called selective laser sintering, where you have a powder that you can melt. It could be plastic, it could be metal, it could be anything, and the laser, it melts it in very precise ways. And when you're done, you end up with your model or whatever your product that you're making that's sitting in a vat of the dust that it's made of, and you just basically shake off the dust, brush it off, and then you have your product. There's SLA, or stereolithography, which is very similar mechanically to SLS. Actually, I got that backwards. SLA was the first one invented. I apologize for that. This one is where instead of using a powder, you use a resin that is photosensitive, usually to the UV spectrum at about 420 nanometers. That when it gets hit with enough ultraviolet light, it actually polymerizes and turns to a plastic. So these printers are also a very similar technology, which I'll get into, is actually coming down in price a lot as well. Still a little bit more expensive than the next one, which is fractional deposition modeling or fused filament fabrication. You will see these two terms used interchangeably. This is that they mean the same thing. The difference between FDM and FFF is that FDM was trademarked by the man in the company that invented this type of 3D printing. So basically, the difference between FDM and FFF is the difference between calling something a Q-tip and calling it a cotton swab. The patent I think expired in 2009 from the 80s on this. So that's when the floodgates started to open up. So I'm just going to go through them real quick. I already talked about it a little bit there prematurely. Thin layer of powdered material is heated and fused by a laser. Each new layer of powder is deposited and smoothed by a little arm that comes across, and the laser fuses that. And then you just kind of wash, rinse, and repeat that until you have a total product. This one is a really cool technology, but it's still a really expensive technology. You're not really limited by the type of material as you are in some of the other ones that you can do, but it's still pretty pricey. Although I can only imagine that the price for this will come down as well. Pros of it, this allows very fine details in the product. So if you're doing models, very fine modeling, like I said, you can do a wide range of materials, including metal, for this the out of the box. And one of the really cool things about this, and one of the frustrating and more difficult parts of 3D printing, is the support structure that's needed when you're doing it. This SLS inherently does not need it, because it's basically, you have a pile, the thing comes out in a pile of dust that you just brush off. So the support structure is sort of inherently existent in the printing process. And of course, this is the unused base material can just be recollected and reused in many cases. So it does minimize waste, as do all the additive manufacturing. So currently this is mostly in commercial use because it's still expensive. You do have to deal with that powder, and powder can be troublesome. I mean, even non-toxic things, if you powder them and inhale them into your lungs, it over time can cause a lot of problems like interstitial lung disease and even cancer and things like that. And you do have to clean off the model when you're done. But like I said, it's just a powder. You just kind of brush it off, and you probably can rinse it off with water. You don't really need any solvents or anything like that. And I don't know why I put recycling the unused portion under cons. The other technology, very similar, as I said, of stereolithography. This also uses laser. It zaps the resin. This is commonly called resin printing, which is actually refers to a few different things, SLA being the prototype of it. You basically draw each layer with a laser. This is also, like SLS, being very similar in terms of mechanics, is capable of very fine detail. And the laser is controlled by movable mirrors. The negative of this, it's still on the pricey side. You can get a very good SLA printer for under $2,000, but when you see the prices, that's like 10 times more than the prices I'll be talking about later. But it's slow, is one of the things. These are all slow, but this is one of the slower ones. So many of the earliest printers, like I said, use this. The production cost is still pretty high because it's not tolerant to problems with the targeting of the laser. A lot of people you'll hear talk about resin printers, and they'll throw around the term SLA as synonymous with resin printers, but it really isn't. It's a subset of resin printers. It's the prototype of the resin printer. They came up with ways to make it cheaper and easier to use. Some of these are MSLA or masked sintered laser masked laser, which uses, I'll talk about, or DLP. DLP you might recognize as digital light processing. You hear about a lot in the projectors that you see both for home theaters and computers. The reason is it's the exact same technology. The only difference is that in this case it uses the UV spectrum. So it projects an image of the layer that you want to harden in the resin, to polymerize, and that's how it does it. It's so there's a build plate that's down in the bottom of the resin. You project the image on that. That makes a little thing. The build plate moves up a little bit, project another layer, and it keeps going up. That also is not. It's significantly cheaper than using lasers to do it. But they were able to make it even cheaper by using a technology called MSLA, or masked SLA. This is a lot of consumer grade resin printers that are on the market now and are very reasonably priced, are this masked SLA. Basically, it has a fixed UV source that is able to shine on the entire build plate, and they interpose an LCD screen that blocks selective portions of it, kind of like a negative. Basically, we went backwards. We came up with DLP, digital projectors, and they said, you know what, we can make this cheaper and easier to use if we go back to the old technology of basically mixing things together and having using a negative, except one that's changeable because it's an LCD screen. The benefits of this is it's fast, it's cheap. The big drawback of masked SLA is that the LCD has only a limited number of hours that you can use it before you have to replace it. So it is considered a consumable. They're significantly cheaper than the printers themselves, but it is a cost down the road. I think it's pretty hard on these LCDs to be baking them in UV every moment they're used. I get ahead of myself, don't I? So the pros is these are very fast. They are definitely cheaper than SLA. It's simpler design. But cons, as I said, the limited screen life is the big one. And it tends to be a little bit lower resolution than the SLA. So if resolution is key to you, then to use the laser version, the SLA is the way to go. But that being said, we are talking about relative terms here. The resolution you get on these is absolutely phenomenal. And for the vast majority of uses, I can't imagine that the difference, unless you're doing like some real commercial, doing real art type stuff. I mean, I've printed miniatures for Dungeons and Dragons, and they're just freaking gorgeous on this printer as compared to my FDM printer. The other thing is the SLA is that, and this tends to be why they're a little less detailed, is because they use voxels, which is the 3D equivalent of a pixel. And so it's digital. And pixels being picture elements, voxels being volume elements. You say, where did the X come from? And it's there because VOL is really hard to say, and how else would it be analogous to pixel? So basically, we look at SLA as being an analog type material, and then DLP MLSA is digital. Currently, greater detail is available in the analog version, but just an analogy that I use is I used to say that I'd never see a day when these newfangled digital cameras could produce the resolution that I could get with my 35 millimeter or a large format film camera, and I was of course proven wrong. There's a lot of dust on top of my really nice 35 millimeter camera upstairs in my office. So I just threw in this apocryphal quote from Bill Gates that 640K is all the RAM anyone will ever need. It's said that he said this sometime in the 80s at a computer conference. He vehemently denies it. He said no one in computers would ever say something that he said a lot of idiotic things, but that no one in computers would ever say something like that, because everyone knows there's no such thing as too much RAM. So MSLA is a lot cheaper. It's good enough for the consumer market, except for that problem of having to change out the screen every once in a while. But SLA has one huge advantage over all these other technologies that you can't deny, that makes it that you really are going to want one once you see this. It's freaking lasers in it. And lasers are just cool. Like anything, you put a laser in something, it's automatically better than anything else, even if the laser has nothing to do with the function. Like this shark. So most people, when they picture 3D printers, they're picturing the FDM, or the fractional deposition of materials. It's probably the most ubiquitous one now, because it was the one that got cheap the quickest. There's an organization called RepRap that came out with a build your own one thing. That the founder of the organization's idea was he wanted to make a machine that could build itself, and once you had one, you could use it to print one for your friend, and then so that obviously required a lot of technical know-how and stuff. They're still out there, and you can still get their printers. The way to look at it is it's pretty much a hot glue gun taped to a CNC machine. So filament goes in one end, it goes through a hot end extruder that heats it up, and it's forced through there under pressure and tension, and comes out the other end like icing a cake. But what's a CNC machine, you ask? CNC, just briefly, means computer numerical control. They use computer code to very precisely control the position of a tool that you're working with in a given location. That can then be moved in space according to a recipe that's most commonly referred to, at least in a 3D printing world, as a G-code file. There are other more proprietary ones, but this will be the most common one you have. G-code is a text file with a series of instructions. It's just like computer code, but for a thing that controls a thing. So this is just a quick copy and paste of some G-code, just showing you what it looks like. Anything after the semicolon is a comment in G-code. So that's just, they put the little thing and then they put a comment there so humans can tell what it was supposed to do. So someone coming and reading your code can understand what you're trying to get at, especially if it doesn't work. You should fix it to make it do what you wanted. And of course, the most fun part of 3D printing and the coolest is writing all of this G-code by hand. It's really fun to code. It's a passion of mine. No, I'm joking. There's software that does it for you. You just take the 3D model and it coughs out the G-code. You can do that if that's your thing. So, like I said, it's also FFF. It was trademarked in Sorry. The patent expired in 2009. The floodgates opened. So FFF has the extruder we talked about. It has an X-axis. It's on a rail that allows the extruder to move left and right. It often has a Y-axis. It is usually the print bed itself that moves in and out, and that gives you a 2D move there. And the Z-axis, the extruder is on a vertical rails that allow it to move up and down to print the different layers. There are some models in which the build plate moves away from the head, but it gets to the same idea. A couple of examples here. This is Prussia, Josef Prussia he's based in Prague. He was one of the original pioneers in kits for 3D printers. He still makes some of the absolute gold standard of these FDM machines, but his are kind of pricey. But it's always like, if you have an original Prusa, the one thing is he makes all of his machines on these machines. He has a factory that has hundreds of these machines pumping these out. So you know that he knows how to make a reliable machine that makes reproducible results, because he uses them to manufacture them. And they're constantly tweaking and constantly upgrading them. One of the machines I have is this is getting down into the much cheaper area, the Creality CR10S. You can see the very similar design. They both will come. You have the little, I can see here, the build plate. I don't know if you can see my my pointer here. The build plate moves in and out. This is your extruder here with the hot end is hidden by the cooling fan there. That moves up and down, left and right. This is exactly the same thing, just in a different just a different thing. These are aluminum. Everything's aluminum on this except for the couple of plastic parts. I like this printer. This is one of Creality's kind of, I would put this in like the low mid range of 3D printers. It's definitely not a high range one. One of my first 3D printers that I have, when I burned up my absolute first one by trying to upgrade it like an idiot, is the Ender 3. This is also a Creality product. This one's cheap. Like this is the one that I paid less for than my HP color laser jet. I think I bought this on sale for $220. One of the nice things about the 10S is that because it's moving up into the next price tier, it comes pretty much fully assembled. You do have to screw the vertical part into the horizontal part just because they got to take it apart to get it in a box. But this came all in pieces and I had to put it together. And it was a little tricky. They are made in China and they do have those wonderful, easy to read instructions that always come with Chinese products. I ended up having to watch a YouTube video to figure out how to put this together. But it took about 2 hours and it printed pretty much out of the box. So hopefully I've whetted your appetite and you're interested in what and are curious as to what you might need to get into this thing. You obviously need a printer. We already talked about a couple of those. You need some filament or the actual raw materials, and you're going to need slicer software. The good news about the slicer software is most of them are free, and the good news about the filament is you can get it pretty cheap, or you can get it really expensive if you want the good stuff. But the cheap stuff works just fine for most things if you're not doing anything that you really want to look perfect. And you need a source of STL files. You can have all the printing ability in the world. If you don't have something to print, it's not much worth. A lot of these you can get online. There's a lot of people. This is a big community doing this, making different models, and pretty much anything you can think of, someone's already made it and they're sharing it for free. And there are some websites where they pay them $1 or $2 to get their STL file, or you can make your own. That's one of the parts that I'm having now. A lot of fun with making my own. I think you go through a couple of stages when you get a 3D printer. You're kind of wowed by it and know how to use it in the first stage. And the second stage, you print a whole bunch of crap that you don't need, like little bunny rabbits and things like that, because you're still wowed by it. And then you start printing, you realize that there's a bunch of things you need, and you find files in them online, and then you may or may not progress to the last stage of making your own files. Oh, I left one of them out. The one after the bunny rabbits was you get obsessed with modding your printer and upgrading it by printing things on it to upgrade the printer itself. And then hopefully you don't go down the path I do and burn out the motherboard when trying to put a new extruder on it. But I discovered Creality when that happened, so that was good. Wait. So, like I said, the original Prusa, that actually has come down in price. The kit of it is now $750. It used to be over $1,000, and when I say used to be, I mean like the last time I looked was a month or two ago, and it was over $1,000 for the Prusa printer. But I guess because of the world's complete collapse of the financial markets, he's coming down in price. Underneath there is your build volume, and there's your millimeters, so it has a pretty reasonable build volume. The Creality 10S, as you can see, is not quite half as much, but it is significantly cheaper than the Prusa. These prices are valid as of today. I looked them up, and it has a significantly larger build volume, which is nice. It's not necessary, but having a good build volume does make life easier in some respects, especially if when you're printing things like these masks. And then the Ender 3, the sale was over, so it was up to $250 for that one. That 220 by 220 by 250 is a very nice build volume. And actually, if you tweak the firmware in these things, you can a lot of them you can squeeze out a couple of extra millimeters in the build volume, like 10 or so in each direction, except for the Z direction. And then I just looked this up. Some people want one of these little ones, but it used to be that the minis were significantly cheaper than the full size ones, but since Creality has really come down in price to the 250 range, it's almost not worth buying a miniature one. And frankly, the design of the miniature ones is a little less stable than the other ones. So you're gonna need printer filament for your printer. So basically, like ink, 3D ink, generic PLA that I can purchase down in St. David's at Micro Center is going to cost me about $17 a kilogram. And unless you're printing out like production like things, like I was printing out these face masks. I had 3 printers running almost 24 hours a day. 2 pounds of filament is quite a bit. You'll probably last you months unless you're going crazy with it. It does come in a variety of colors, and other there are other specialty filaments. There's stuff that's more durable, that can more UV resistant, which is actually probably of interest to amateur radio. Flexible ones and even soluble ones. I talked about support structures before. You can get a printer with more than one extruder on it, and you can print your support structures in soluble material, and then just when you're done, drop in a vat of solvent. In some cases, that's even water, and leave it overnight, and the next day you come out and all the support structures have dissolved off of it. And you're going to need slicer software. One of the ones that a lot of people start with is Cura. This is free. It's made by a company called Ultimaker. They make their own 3D printer, so you'll see this a lot. People come out with software and put it out there for free, and they're pretty universally supported by the machines, because the G code is pretty generic, in the hopes that you say, oh, this company's really nice for doing that. Maybe I'll buy their machine. And of course, there's ads for their machine all over their software. Another one that a lot of people use is called Prusa Slicer. This is Josef Prusa's addition to the market. It is also free. It obviously is optimized for his machines too. And then there are a few commercial options, the biggest one being Simplify 3D. This is a really nice piece of software, but as you can see, it costs 2/3 of the price of the printer. So unless you really got into making your own designs and needed some high-end features in the slicer, like really wanted to customize support structures because you're making interesting geometry.
So while Rob is trying to bring that back, I'll pick up here. Thingiverse that you see there, the website, thingiverse.com. Okay. They make the MakerBot replicator, but they have an online database of prints, STL files that Rob talked about, where if you can think of it, a lot of times the design is up there. And that's where I got the mask strap that I've been printing. There was a bunch of them online. I downloaded some of the STL files and printed them. And that's been working really well. I recently was looking for something that I could use in my Go kit that I'm redoing. In your back, Rob, go ahead.
I switched to a different microphone, so I probably sound not as good, but it'll do the job.
Okay, you sound fine.
Yeah, I'm just using the webcam's internal one now. So like John was saying, Thingiverse, basically almost anything you want to find, you can find on Thingiverse. There are a couple of specialty things that I've just Googled, and then there are other websites out there that they tend to come up. I've only paid for an STL file once because it was like something I really needed, and it was really specialized. Basically, I was making a UV sterilizer box to sterilize N95 masks, and needed a 2G11 connector for a fluorescent bulb, and they were all sold out because I think other people were making UV sterilizer boxes. So I paid $1 for the STL file and printed it myself. Okay. So And there are obviously others you can download, or you can create your own. So create your own. Nice. Tinkercad. This is Autodesk makes this. They're the people that make AutoCAD, which a lot of people have heard of. It's free. It's web-based. I strongly suggest you go online and try Tinkercad out. It's just tinkercad.com, and it's just fun. It's really intuitive. It's really easy to use. They have a tutorial built into it, and the nice thing about it is a lot of it's fairly similar in feel to a lot of their other more advanced softwares, which of course is intentional, because I'm sure that the whole purpose of this is to get you to buy their other stuff, and they succeeded in my case. But you could it's a little less feature rich than the standalone software, but it definitely, you can do a lot with it, and it's free, and I mentioned AutoCAD. Also, by the same company, this was one of the big the big computer-aided design software that I was doing some reading into it, because I use a different one that they make called Fusion 360, which I think is the next one I said. AutoCAD is geared more towards two-dimensional, like drafting and things of that nature, but does have 3D capabilities. It is a standalone piece of software, so if you want to run it on your machine and not have to deal with the cloud, AutoCAD's your thing. The only problem is they don't have a Mac version. So if you're a Mac person, I have both. I have my Windows machine that I'm on now. I have a Mac. I have a Mac laptop. But Fusion 360 is very similar to AutoCAD, but it was built from the ground up as a 3D system, and it works very well with meshes and things like that. But it is cloud-based, so you do need to have a working internet connection to use it. Another free option is a software called Blender. A lot of people use this to do modeling for like little miniatures and things of that nature. You can do straight up just like technical type things. It was originally designed, it's open source. It was originally designed as a 3D modeling and animation software. There are actually examples, which I probably should have looked up, of major studios using this to make 3D full feature length 3D movies. This is a very powerful piece of software that you can do a lot with, but the learning curve extremely steep. I obviously have it on my machine because it's free, but let's just say the mouse tends to hover over Fusion 360 as opposed to Blender, except when there's a feature that I really need from Blender, because it's a lot of like keystrokes and stuff that are made for people in industry that already know how to use the damn thing. So it's tough to learn how to use it. So what can I do with it? Basically, in terms of radio, the limit is your imagination is the limit. But here's an example. This may not look like much, but it is actually the VFO knob for a Yaesu 857. I lost mine, I noticed one day, and I couldn't for the life of me figure out how to buy one from Yaesu. So I said, screw it, I'm just going to Google it. I found it on Thingiverse and I printed it out, and now I have a VFO knob. I apologize for the quality of that. I was experimenting with a larger nozzle on my printer, and I didn't care enough to switch it back down to the small one to make it look nice, because it's just a functional piece, and my paint job sucks, so I apologize for that. What else? You need an inductor. You have some wire and a 3D printer. You can calculate the size of the core and the number of turns, design it in Tinkercad and cough it out, or just download one off of, this is off of Thingiverse, I just did for an example. And you can have an inductor of any value you want within hours. Actually, this probably would print within an hour or two, to be honest with you. Might as well celebrate Nikola Tesla's birthday, even though it's not today. He did invent radio, in spite of Marconi's claims. The Supreme Court of the United States agrees. Of course, he dropped dead about 6 months before they did agree, but but you're gonna have to wait till July 10th because that's his actual birthday. So this is actually this idea here that it has an inductor coil. It's basically a miniature Tesla coil that powers this is an LED thing wirelessly just to look cool. That falls under the printing of things we don't need category. And then I just saw this today. I just typed ham radio and into the search of Thingiverse, and boom, out came a key. There was a lot more examples out there. I'm definitely going to be building this probably this weekend. This works on the I read a little bit into it. It's 20, 40, and 10 megahertz bands. It's a ground plane antenna. Looked like it had really good low angle as a vertical should. And so basically you print out the loading coil and it clips to a telescoping pole there. And you use a wire, and boom, now you have a portable vertical. There's the answer to the other antenna for a field day right there for DXing part. So, I don't know what your thoughts are. If you want, I could pull up Tinkercad. I mean, if not, or Fusion C360 if you just want to see the interface. I'm gonna open it up to the gallery here, and you tell me if you have any questions, or if you want me to show you a little demo. This is the end of the formal portion of the talk here. So I'm gonna, I think, yep, that's it. So stopping sharing, go back to normal, and I will unmute everybody. Hopefully that won't cause some horrible feedback incident. So
This is Jill. I just wanted to pipe in a little bit because actually
Jill wanted to abuse me, so I'll let her go first.
because I've actually been doing this for 20, 25 years. We've had, my first machine that I had to buy was $250,000. that was the abuse I had to give you. It's like, it was the Stratus 900, which is the footprint is 2 foot by 3 foot by 2 foot, so it's got the biggest footprint out there. And that was probably 10 years ago, so it was a little while. But the one thing that I kind of wanted to pipe in on, one is there is actually some applications now that it is cheaper to do mass manufacturing with 3D printing. It depends on the complexity of the part, as well as, you know, the size and various other parameters, but they are finding more and more. So some of the auto manufacturers even now are starting to 3D print instead of, you know, CNC. The other piece that anybody that was interested
Joseph Brusha is one example. Like he's making his printers that way.
Right. And so there's also NextFab. I don't know if you guys have heard of NextFab in downtown Wilmington. They actually have a wood shop, I don't know, or metal shop. I forget there's one in Philly. I forget which one has wood shop, but they also have a 3D printer and a CAD station too. So if you didn't want to invest and you just wanted to, you do have to get membership, and they do get you by, you know, you got to train officially, and so you got to pay for all of that, but that's out there too.
The most Newcastle County libraries, I'm not sure about the rest of the state, they all have they have 3D printers as well. There's no fees whatsoever other than just getting a membership.
Yeah, good. I didn't know that piece. The other piece, I guess now I have to like complain a little bit, because I have to admit I've seen some things on the internet about using parts on respirators and stuff. So I personally, actually, when I heard that, thought I would rather die at home than go to a place that is using 3D printed parts that someone didn't actually design. So there's a difference between design and engineering. And so if you don't know what the heat resistance are, you don't know what the strength needs, or the chemical reactions, or the porosity and the strength. I mean, for masks and stuff, that stuff is great. But you have to be a little careful. And I can tell you, even as I was training some of the younger engineers that were coming through my group, they got the same as design engineers. They got the same enthusiasm, and they started 3D printing everything. And I'm like, whoa, guys, this is not a magic material that can do anything. So you kind of have to stop back and think about what the polymer is that you're using and whether or not it's applicable in that particular application. If it's something that's like a ventilator. Obviously, if it's something if it breaks, it doesn't matter. That's a whole different category. So anyway, I got off my
I think the only situation in which they would use that was basically if the choice was between death and using it. So it's like, for instance, the other thing that they were some places actually doing was making Y splitters and putting 2 people on the same ventilator, which is also a horrible idea unless the choice is between that and death, for many, many reasons, like including if the compliance of the lungs of one of the patients gets stiffer, which is going to happen with this disease, then the other person's going to get ventilated more and may even get ventilated too much. And so it may kill both of them. So just to go along with what you're saying.
Anyway, so I'm off my. But yeah, that was really good. I haven't actually played with the home ones much, but I wish I was still working, Rob. I could take you into we actually have a 3D lab with all kind of industrial size 3Ds and just down Chestnut Run. So. But
it's I have now I have 3 of the FDM printers, and 2 Ender 3s and I guess 4 if you count the one that doesn't work on the floor that I burned out the motherboard. And then I bought one of the resin printers. The prints from the resin printer are gorgeous, but man, is it a pain in the ass. The resin's toxic. It gets everywhere.
and it's expensive as well, isn't it?
The resin?
Yeah.
It's definitely a lot more expensive than, expensive is a relative term. Because the build plate on my resin printer is about like 4 inches by 2 inches. So it's not like I'm printing out big beasts of things. That's more of a novelty than anything else. Like I use it to print little figurines for Dungeons and Dragons, basically.
So all of that said, I still miss when back in the day, that I'm really dating myself, we actually had a wood shop and they used to carve out prototypes for us out of wood. So
that's the thing with the same technology, the CNC technology that's used for the FDM. The other thing is, the other big part of it, there's laser cutting and engraving, which NextFab has. And also you can put a router on it and print it out. And it's just,
also CNC water jet.
Oh yeah, we had access to it. Yep.
So I had a couple of comments. One is a related technology that you didn't mention. I thought I'd mention is there's a thing that works a lot like selective laser sintering, except that instead of using a laser, you use an inkjet printer and you print glue, basically. And there's a I can't remember the name of the company that makes a whole collection of these machines, but basically they use cornstarch as the material, but it's otherwise exactly like an SLS printer. It just has an inkjet head, or some of them actually have multiple inkjet heads, and you can print colored objects that way, which is
that's cool.
And then the only thing is they're very fragile. So when you vacuum out the dust at the end, and then you basically soak the whole thing in cyanoacrylate to turn it into something that's actually robust.
So it's
I've used one of those, and they're actually great. The other thing I wanted to say is a ham radio related use of 3D printing that I haven't heard mentioned a lot is producing tooling. One of the problems with homemade devices is front panels that are not horrible. And so one of the things that a lot of people have been doing lately is they actually use PC boards for their front panels. Like, I don't know if you can see it, but here's a device that I recently got. This is a Chinese made EPS disciplined oscillator made by a ham in China. And it's using basically just this circuit board as its front panel, as a way of getting a precision milled front panel. But another thing you can do is you can use an FDM printer to make a jig that has the exact right sized holes in the exact right position, and you then place the object in that jig, and or I guess technically it would be a fixture, and then you can drill through it to make it. So here's an object I made that way. This is a receive antenna controller, and it had to be very precise because you see there's this switch, right? And it has to line up with the lines here. And then these have, these are actually light pipes that go to LEDs that are on the circuit board in the back. So everything had to line up very precisely in order for this to work. And the same thing is true on the back. I've got all these holes and everything. Everything had to line up with where the circuit boards are. And so I produced two jigs using the, actually three, because I drilled the holes in the bottom the same way. I printed out 3 jigs. Actually, I went to the Chester County Library and I had them, I took them an STL file and they produced me some things in an afternoon. And I went down and got them and then took them home and drilled them, and that's how I was able to make that. So that's actually proven to be a very useful technique. If anybody else has that particular problem, I can recommend it. You can't do a lot of mass production that way because the jigs wear out, but it is a great way to get your holes exactly where you need them, which is often critical.
Can you hear me? Sorry. I think I double muted myself.
Hey, Rob?
Yes. Dave.
If you have a broken piece of plastic, is there a way to capture that into a file and be able to reproduce it?
Yeah, there actually are 3D scanners out there. That's one thing. But I found I don't have, they're actually, they get a little pricey and they're questionable quality still. But I just open up the CAD software and just basically I pull out my calipers, measure the thing, and make a new one and design a new one is how I've been doing it.
Well,
I have seen. Sorry, go ahead.
I'm gonna say this goes back to my Kenwood tri-bander from 25, 30 years ago. There's a little piece of L-shaped plastic. It's probably no more than 1.5 inches long, maybe 1/8 of an inch thick, if that, and it acts as a spring for the front panel push buttons.
I probably could make that fairly easily. To be honest with you, the first step that I always do with something like that I left out is Google it and see if there's an STL file. Someone else may have already made it, because I don't reinvent the wheel. But yeah, I mean, it sounds like just from the thing of it, it should be pretty easy. Even if it's not out there to design it, then we put it on Thingiverse, and then it's available for other people if they have the same problem.
Yeah, I've never done any of this stuff, so I have no clue as to what what may be possible.
Just anything.
The knob's a good idea. I have a 732, Kenwood 732A. The squelch button, it's either the squelch or the volume, but it's the same identical knob. It's a 20-year-old radio, the knob's missing. And if I had the knob, it'd be like, I'd be able to use the radio. So that's actually a good idea.
John was complaining about this very similar problem, and I had already found an STL file online by the end of the conversation, and it was already printing. And I handed it to him. I forget whether it was later that day or I drove over there the next day and handed it to him.
Which knob was it? What was it for?
Was it for the scanner?
Yeah, Uniden scanner.
No way.
That's pretty funny.
I was going to say, even recently, I've been messing with those things for I'm given to the caregivers at Christiana Care, and so I have the Harbor Freight boxes. If you guys watch my N3LUD YouTube channel, where I've made various shelves, and there was recently, I was trying to put something, when you open up the Harbor Freight toolbox that has these removable bins on the inside, and the largest one was a little too small for what I needed. And I was like, oh, I wish I had one double that size. Well, lo and behold, there's like a dozen different people that have designs up on Thingiverse for the inserts for the Harbor Freight boxes. So you can print extra ones, all little ones or medium ones, so you can kind of,
Do you have it in front of you, John? You can show it.
I don't have it in front of me. It's actually in the workshop. But the one thing that I do have in front of me that I printed is a handle. This is actually a piece of plastic that
It's kind of fading in out, John.
Your background's fading.
Yeah, probably use,
let me turn that off here. Hang on. Let me turn the virtual background off.
You may have to dim your light. There you go.
I just did. So it's a handle here. You could see that's one
Yeah,
part
I've seen
of it.
that.
This is the other part of it. So check this out. Somebody came out with this when the COVID thing happened. So if you could imagine, this goes over like one of those little L-shaped commercial door handles. So you can walk up to it.
Forearm.
Use your forearm to latch in and then pull down and open the door.
Basically, the way to think about it is, and if it's made of plastic and it fits on my build plate, give me enough information and enough time and enough willpower, and I can make it.
And Rob, this is Jeff. Bill plate. How big is the bill plate, Rob?
Oh Lord, I had that in the thing. I think on the big of the where's my PowerPoint? I'm gonna pull it up. The CR10S is my big one that had a 300 by 300 by 400 millimeter plate.
Hey, Rob, Jeff Backus, I got a question.
Yep.
First off, I apologize for coming in late, and I probably didn't have my mute on right away. But when this is the 3D printer is, I'm assuming it's heating up the polymer and spraying it. Is there any kind of odor to the process?
Actually, I said this earlier. The better way to think, it doesn't spray it, not this one. Think of it as, do you know what a CNC machine is? Like where you can it's take a CNC machine, take the router off of it and put a hot glue gun there, and that's what it's doing, and a filament instead of a stick. So it's basically just melting it and forcing it through an extruder.
Okay. Is there any kind of odor?
It depends on the material you're doing. So with the PLA, which is polylactic acid, there's not really any odor. Actually, I've turned the heat up too high and burned the stuff, and because it's lactic acid, like it smells like caramel. The ABS, which is a very common plastic that things are made of, that I haven't printed with, but I hear that does have an odor to it. It really depends on which thing you're doing. That has been pretty much superseded by a plastic called PETG, and I forget what the acronym stand for. That
glycol.
That doesn't really smell at all, and it has a lot of the benefits of ABS but it's a lot easier to print and a lot less horrible to your life.
Well, I just asked because, would this be applicable for a ham shack or outside in somebody's garage?
Yes.
Yes. Mine's sitting on I don't have the lights on here, but let me see if I can turn that one on. I don't know if I'm on your thing. Mine's sitting right there next to one of them at least.
Okay.
The other two are in my basement. The resin printer I probably wouldn't want to have in my ham shack, just because that does have an odor to it. The resin is toxic, but that's a whole different technology. So that's down in the basement, like at the big unfinished basement part of my house.
And I've had, and Jeff, you've been in my workshop in my backyard. I have literally been printing for 10 weeks, 16 hours a day. I've been printing these mask straps, and you walk in my workshop right now and you wouldn't even know that I was printing anything. There's no smell. And I'm using,
other than hearing the stepper motors going.
Yeah. And it glows. It looks like there's aliens. Like you can look, you pass my house at night and like in the dark, and you see like this red light glow coming from the workshop.
Oh, the MakerBot has a light on it.
Yeah, it has like a red light that you hear. That's kind of, there's some kind of laser or something there. But it's other than that, you wouldn't know. You couldn't walk in and smell it and say something was going on here.
We have to check Dave to make sure he's not dead.
Oh, Dave Scott, yeah.
Putting everybody to sleep here.
Yeah, you're so bad.
Google the picture of Angelo Bruno back in the 80s when there was a mom
yeah.
in South Philly.
Oh,
You know,
It looks
there's
just
a
like that picture.
there's a
That's a picture.
YouTube video. There's a YouTube video of a guy snoring while has his Vox on.
I've seen that. It's hilarious. I was going to say,
That's great.
regarding to what you were saying about the 3D scanners, Rob, I have seen home built versions for under $100 using a couple of different webcams and some software that somebody wrote, and it's some pretty impressive results. And obviously, if you have a 3D printer, you can 3D print the parts, most of the parts at least.
But a lot of the thing with the 3D scanner is you just get the outside surface.
Yeah, that
so
is true.
the internal structure is a mystery to it. Unless you want to build a homemade CAT scanner, which is possible, but I advise against.
And the other thing is when you get the slicing software that Rob's talking about, the various Curin and the other programs, on MakerBot I use one that's called MakerBot Print. You can pull up these STL files, you can import them into what's called a project file in the MakerBot world, and you can tell it what percentage of infill you want. So you could actually do like more of a honeycomb or not. Like there's the ways that you can kind of tweak it to use less material to see if it's like, you don't want to use maybe a bunch of material and then find out like, oh, I need to change the size slightly. So you can kind of mess around and tweak some of these things. And it's pretty interesting. At University of Delaware, where Justin works in the Maker Gym, they have it's a manufacturing site, and they have various printers. They have 13 of them, and they were doing something where they were partnering with an online company where people can send prints to them remotely. So let Rob take over because it looks like he's sharing his thing here.
No, you can talk. I'm just showing.
Okay.
This is CAD because you mentioned it. It made me think of it.
And if you wanted to do something, there's places online where you can give them a model, and they'll print it to you and send it to you. So if you had 10 of something you wanted to print, or just a knob for a radio that you needed, you could actually print it online and then they'll send it to you. You know, you can do things like that. Yeah, pretty interesting technology, really. I mean, it's interesting to hear Jill talk about what was available 25 years ago. And I recently was talking to somebody, had a friend at Boeing that said, oh, we were doing 3D printers years ago. But like this, putting it in the hands, this is almost like when computers, you couldn't use a computer in the home because they were too expensive, to operate, or too expensive for people to afford. And then personal computers became available. The whole 3D world reminds me of kind of when that was happening years ago, and now it's in reach that a hobbyist or a maker can do these things. So it's kind of exciting.
Yeah, actually, you reminded me, John, that and no laughing, but I actually started college right at the time when slide rules were going out and calculators were coming in. I actually could not afford a calculator when I started school. I had to borrow one for tests and stuff.
Wow.
Yeah, so that was, and now that just sounds ridiculous that you couldn't afford to have a calculator, but
yeah,
it's expensive.
Exactly.
Whoa,
like anything else, more the technology gets faster and cheaper, and then you can get it into someone's hands that's a hobbyist, and then there's additional things that people figure out what to do with them. Now, Rob was actually doing some masks for some of the doctors at work, and he was even putting their names in the top of them, I think.
Now, when
I was just showing off.
Now, when you were talking about ear protectors for people, I've been hearing things about that. I understand the need for it because you could cut your ears. What does that even look like? And
I don't have one right in front. This is
It's,
kind of
it's actually not to protect your ears from. It's for the masks, because there's like the masks that flap on the back of your ears.
Well, that's what I figured. It was the mask.
They're just uncomfortable.
You can't see it here. I have one that I was messing around with putting something in, but I never peeled.
You ended up looking like Prince Charles after a while.
Yeah, this one you can't really tell from the video, but this is the raft, the bottom part. It's like a fishbone pattern up here, and it kind of goes around the back, and then the rubber bands hook onto it. So
I see.
It just kind of hooks on the back, so it takes all that pressure off your ears. There's some people at work that are wearing the masks long time, and it was starting to cut into their ears. So that's why the need for that.
Yeah, that makes sense.
They're good if you got to wear a hearing aid as well.
Oh yeah, good point, Jeff.
Hey, Rob, do you have a mask in front of your camera that you could show us?
A shield?
A shield?
I don't have the actual shield part, but I have the part that I printed. Let me, am I up on the people's screen? Because I still see.
Yep.
I don't know. I can't
Yeah.
see myself for some reason. Hold on, let me see. There we go. So this is,
Yeah.
so this is the one that I settled on. It basically sits on your head like this, and you use a 3-hole punch offset to, you set it basically to a 10-inch piece of paper, and you punch one hole, flip it over, punch another on the acetate for a overhead projector.
Oh, that's cool.
And that pops right into those little holders right there. And I beveled the edges on the bottom with a pair of scissors, just because that's what masks look like, so you don't look like a jerk when wearing it. It comes down to about here, and basically protect, because you do it long ways, so it's 11 inches, or sorry, yeah.
11,
Wow, cool.
8.5 by 11. Yeah.
Yeah.
Cool.
That is really cool.
Yeah,
I could punch probably 15 of them per run, and just do a whole box of 100 of them in less than 5 minutes.
And
this takes about an hour and 15 minutes to print. I stacked them one on top of each other so that I could just set the printer and go to bed, and pray that it doesn't burn my house down, and come back in the morning and there's a stack of them there.
I've seen some people have actually been able to integrate in the G-code a system that will actually, stack up a couple of them, push them off the build plate into a cardboard box or what have you, and then go back and continue printing, which is, it's interesting. I mean, risky kind of, because you can, risk something detaching from the build plate or what have you, but it is pretty cool.
Yeah, I saw that video is actually really cool.
When I think Prusa, Rob, was that the Prusa design that you landed on?
This one is 3D Verkstan from Sweden, I believe.
Okay.
And Prusa made a very good one. I settled on this one because it was Prusa's takes, at least on my printer, it took like 50% longer to print.
Yeah.
And it used more material. So it is a nicer design, but this was like a compromise design that allowed me to print more of them for cheaper, faster.
Okay. And when I first saw 3D printing on TV, it was interesting. Like some of the samples that come with MakerBot, there's a screw and there's a bolt that I have a couple of them around the house, and my wife was like, these look like they're reproducing because they're popping up everywhere. And there's an adjustable wrench, and I years ago on this old house, when they were doing something with a 3D printer, because they were doing a house that somebody worked for a company that did 3D printers. Anyway, long story short, they had an adjustable wrench, and he says to Kevin says, well, I really would like to have that. And the guy was like, oh, well, here, it's yours, because I could just print another one. And it's weird when you think about that, because yeah, that makes sense when you're talking about like printing on a regular computer printer, like paper, color, things like that. But when you have an object that moves or you could interact with, and then you think, oh, I could just print another one. Some 3D printers on the market, like Rob was saying, they have you print spare parts, print gears and things like that, so that if any parts break, you can have a spare part that printer kind of created. So it's kind of interesting to wrap your head around, but there's definitely some practical.
Yeah, I actually have one of those 3D printed adjustable wrenches, and actually we did ours with 2 different types of materials. So the screw part is a hard plastic black, and the body of the wrench is blue elastomer. So it's like if you hold the wrench up, it just falls over, bends over, because it can't obviously, just for fun.
Oh, that's interesting. That's neat.
There's a great demo in the early days of SLS machines where they would print a hex head bolt with a hex head at both ends, and the nut already threaded on it, and the nut would move because there was a tiny gap.
That's the adjustable wrench. Actually, I forgot to. I wish I had a camera that worked. I actually have a 2 foot by 1 foot 3D printed dragon.
Oh, neat.
Oh, wow. I just put in the chat. I don't know if you saw that. NASA actually designed and sent an STL file to the International Space Station. They also have a 3D printer. They do have the STL files available on their on the website at
They
the
do a
link.
wrench, right? They did the wrench.
Yeah, and like Rob was talking about earlier, it sort of prints in place. So obviously the ratcheting mechanism will actually function. Obviously, it prints together, which is pretty impressive.
Yeah, that's pretty cool.
So this is Fusion 360. It's similar to Tinkercad, but it's a lot more powerful. It's made by the same company. So like, basically the way you think about it is a 3D object is just an extruded 2D object. So I will draw. I kind of picture what the shadow of the object would look like, and I can print it here. And this is you can do parametric things where you set the you can set the exact dimensions of things like this, like make this a square. Then basically you then can extrude this out to whatever. What was that, 75 millimeters, I think. So you can make a little cube like that. And basically you can do anything like that you need to do with stuff like that. This is really powerful software, and it's pretty, once you get the hang of it, it's pretty easy to use.
Can you also do sweeps and rotates and?
Yep, that's really, you kind of read my mind. That's what I was about to. Actually, I probably should have made that.
Yeah, this is one part that I'm interested in getting more involved in. I haven't done anything with creating my own models. It's all been printing things that are readily available. But I do want to kind of create my own.
So then I can pick this guy here. Let's do it solid. And then you can rotate. And you can choose, like, see, made a little teardrop thing there.
Oh, neat. Look
So
at that.
Rob,
The thing that I often use is where you take a series of 2D profiles and you stack them up in 3D, and then you connect them with the spline to make a solid object.
I think you can do that. I still consider myself a real beginner.
Yeah, I can't remember what that's called, but it's like, I find, yeah, there you go. Just like that cone thing. That was exactly one of them.
Loft.
Which?
The one with the cone with the square base. I think it's further up.
Up to loft.
Yeah, loft. That's what it's called. It's called a loft. That's right.
Well, obviously, I don't have the. So you would basically do like, you're saying you would draw a, like, say a square down here, and then maybe a circle above it or something like that.
Just exactly that. Yes.
So Rob, since you're starting out with this, would you tell people that it was better to start from scratch with models, or would it be better to import somebody else's model and modify it as when you first started out?
I like starting from scratch, because one of the problems I run into with importing other people's models is a lot of people use Blender, and Blender is gotta finish Sketch first. Blender is a really powerful software, and it's free, so I think that's the reason they. Oh, there you go, like that. But it produces a different type of mesh than this, which is a little bit harder to work with, because it's really is designed for 3D, like artwork. So this is the difference between the two, is that's surface based, and this is a parametric thing where you actually put in the parameters here that you want, like that's like you saw. And one of the cool things about this is I can go back to the sketch and say, oh Lord, I forgot I wanted to make this a certain size. So I can go back in and say, 85 millimeters, make it bigger. And then when I go back to finish the sketch, it changes the 3D object automatically.
Yeah.
So I do a lot of I go around with my calipers and caliper a lot of stuff these days.
I've used the lofts, by the way. I've used them to design sheet metal stuff. Like if I need a custom transition for a dust collection fitting or something.
And this does have the ability like to render, and it can do tool paths for CNC and things like that. And you can make it. You can do a sheet metal. You can do sheet metal on this as well with the Fusion 360. This is basically a multi-purpose. You can make different tools. You can actually do different components, and it'll automatically put them together and make sure that they fit. And you can simulate the action of your creations in the computer before you go and print it out or mill it or whatever you're doing. And my new fun thing is I've been making a lot of engineering drawings just because I think it's cool. From the
Oh, that's pretty cool. Yeah.
You can you can actually crank out the drawings, and then so you can do. Wait, let's see if I remember how to do this. You can do like a projected view, and it automatically changes the orientation from your base view.
Yeah, I used to have to do those by hand on Mylar. Handful.
Yeah, either a W or a D drawing.
Dimension them, so you can tell it what the dimensions are. So.
Yeah, cool.
That really doesn't have much use for me because I just basically cough out the STL file and print it. So I don't really need those drawings, but I do it just for fun.
Yeah, that's awesome.
It's all really cool.
Anyway, we can kind of close out the meeting at this point. So thank you all for joining. Appreciate it. Thanks again to Rob for doing the presentation. And I would say I'm interested in doing more of these virtual meetings. I kind of feel like I'm more connected with people now doing this virtually, being able to look at you all in the face and stuff. And it's not like, oh, now you get done 9 o'clock, you got to go walk to your car and drive home and all that stuff. You're done, and you can just flip on the TV or whatever you're doing at home. So I liked the virtual meeting. I'd be interested to hear what everybody's thoughts are. Even if we do the virtuals, I still think maybe once a year we get together in person for an actual meeting. I know we see each other in person for other different events and things, but
maybe do it like a drill, like the once a year a drill, and then or more often, and do the virtual for the meetings.
Yeah, right, exactly, right. The things where we could do virtual for doing a slide deck and sharing and stuff. Because quite honestly, I think seeing the screen here with you sharing your screen, Rob, or I think it's easier than doing it even at the hospital.
Oh yeah,
overhead and this isn't working, and
you're not like squinting to see something that's halfway across the room.
Yeah, exactly. So I think this, I loved it. I thought this was great. I'm looking forward to the next one, and I think the next one's scheduled for August. But I think, let's see what happens in August. But maybe we could do one every other month. I mean, even if we got together for an hour and did some small little 15-minute topic or something, maybe, I don't know. It feels like maybe we could be connected a little more often. I liked it. I thought it was good. So.
I think it seems like we should be able to train. Like I can imagine when you guys were helping me through the digital stuff, if we did the radio and this at the same time, and then I can just show you my screen and go, this is what it looks like. What am I doing wrong?
Yes. Great idea.
Yeah, John, I'd just like to say, because I'm working, I'm at work right now. I'm working usually when you have the meetings. I'm working when you have the nets. From over here at the university in Westchester, it's tough for me to hit the 7.3 machine, things like that, to get into the nets. So this is a great thing. Really love it, and excellent job there, Rob. Really appreciate it. That's real interesting. Thank you.
Yeah, maybe I'm in front of the computer when I'm running the radio net, and I'm in front of the computer anyway. Maybe I should send out a Zoom link, John, and then you can connect up with on Zoom like I was doing with Jerry, KB2GCG for years. and then you can just still check into the net, and you're doing it over Zoom into the radio. Maybe we could try that if you want, since you're working when we're doing the nets and stuff. I don't know, just a thought, like, why not? I mean, if there's anything positive that's come out of the whole COVID-19 is all the different people that either tried to do something a certain way, or projects at work, or people being able to work. I mean, Nationwide Insurance had 20 something buildings that they're going to be consolidating down to 4, because they said that they're still meeting the same key performance indicators that they are by having people work remotely, and the companies in New York that are saving money on real estate. And so, I mean, maybe we just do things a little different, and just, that's the one thing I think that the pandemic caused people to think differently, and barriers automatically were like, not there anymore. And projects that were taking a while were like, we have to stand this up quickly. They did that at Christiana Care for virtual care and all kinds of stuff that they were, doing for a while, but trying to stand up even more and more and more. When you're forced to do it because of something going on in the environment, now all of a sudden it happens much more quickly. So that's a positive thing. Anyway, it was great seeing you all. I appreciate everybody's time this evening.
And I recorded this, so I'll see if I can figure out where it actually went.
Oh, nice.
I said to record it on my computer, but it didn't ask me where I wanted to put it, so I have no idea where it went.
I don't know. I've seen it. The screen's been saying recording the whole time, so I have no clue.
It's somewhere.
It'll probably tell you when you stop the recording, because it's still recording.
Yeah, we just got to be.
Maybe
We probably
it's
don't want
in the cloud temporarily or something.
Really big file. That's what you do. Look for the really big file somewhere.
It'd be also good to try the mesh network
We're swearing the whole time.
and see if we can do this with. I don't think Zoom. We can take Zoom off of the internet, but we see what possibilities we have with the mesh network.
Well, there is a gateway. I mean, there's a gateway on the mesh network to the internet, right?
Yeah, there is.
Yeah, it's at my house.
Oh, sure, there's.
Yes, but there are video conferencing things that are not centralized that you can use on the mesh entirely. So there's another thing you could experiment with if we wanted to.
Because we got to worry about things like encryption. We can't encrypt on the mesh network legally.
Right.
Well, why would you want to?
Well, the encryption's built into some of these things.
Yeah, it might be automatic.
Yeah, automatically. So,
My question is, how do you serve?
It's just digital data.
Yes. No. They need to get rid of that restriction.
Well, it's just digital data. I mean, you can play music over the amateur radio if it's digital.
You can't encrypt for the purpose.
That's true. As long as it's not a phone emission.
Yeah.
Yeah.
But it doesn't. They don't. Do they specify that you? I mean, they don't want you to encrypt digital stuff.
It's just data.
No, that's true. But I'm saying there's no, because you're not allowed to put any kind of music on a phone transmission. But there's no reason you can't do it on a digital emission.
Which is a funny rule, considering now all of the commercial radio stations are digital.
Yeah, don't tell the SEC that. They may not have figured it out yet.
That's funny.
We just told the NSA.
Yeah, seriously.
Well, yeah, they already
encrypt if you publish the encryption keys.
Okay.
Well, that's
Catch you later. I got another Zoom meeting to go to.
Yeah, if you publish
Hey,
the
there's Dave.
Yeah, but it might not be possible with that.
Do Mr. John.
I did.